Hello students, I am going to explain the oxidation numbers, how to calculate, how to find the oxidation number for any compound or element in chemistry. Okay, for that there are some rules. If you know these rules, we can calculate the oxidation number for any element. If you know these rules, we can calculate the oxidation number for any element, right? So first, free element oxidation number is 0. Free elements oxidation number is 0. What is meant by free elements? If you take sodium, magnesium, right, P4, S8, these are free elements. See, they are existing individually. They are not mixing with another one. If you take NaCl, Na is mixing with Cl, not like that. They are existing individually. So they are free. So we can say the free element oxidation number is always 0. So carbon C4 oxidation number is 0. Next, coming to the neutral elements. Neutral elements are compounds, oxidation number is 0. If you take CO2, right? If you take H2O, if you take NH3, so these are neutral compounds. Neutral compounds oxidation number is also 0. The first point is, for free elements oxidation number is 0. For neutral compounds the oxidation number is 0. Coming to the third point, fluorine always show the oxidation number of -1. You should remember this. Fluorine always show the oxidation number of -1. First remember these points. While calculating, you will get more clear idea. While calculating oxidation numbers, you will get very clear idea. First just remember. Okay. Fluorine always shows -1 oxidation number. So group 1 elements always shows +1 oxidation state. Group 1 elements always shows +1 oxidation state. What are the group 1 elements? Lithium, sodium, potassium, rubidium, cesium, francium. So these are the group 1 elements. Lithium, sodium, potassium, rubidium, cesium, francium. Group 1 elements always shows +1 oxidation state. Coming to the group 2 elements always shows +2 oxidation state. What are the group 2 elements? Beryllium, magnesium, calcium, strontium, barium, radium. Right? So francium and radium are radioactive. Right? Francium and radium are radioactive. We may not consider while doing the calculations. Okay. So group 2 elements: beryllium, magnesium, calcium, strontium, barium, radium. If you calculate the oxidation numbers for an ion, the charge is its oxidation number. So sodium oxidation number is +1. Calcium, the charge is its oxidation number. Calcium is +2. Right? In H2O, what will happen? In H2O, I need the oxidation state for hydrogen. Right? In H2O, I need the oxidation state for hydrogen. Right? So how to do this? So generally, the whole molecule is neutral. So I want to find the oxidation number of hydrogen. I will take this as X. Remember carefully, observe carefully. I want to find the oxidation number of hydrogen, so that I will take as X, right? But how many hydrogens are there? 2 hydrogens, so 2X. Oxygen always show -2 oxidation state, except 2 other cases. What are the 2 other cases? I will tell you. Now remember, so in this case, oxygen shows -2 oxidation state, so 2X -2, right? This is 2 hydrogens. Hydrogen we need to find. So 2X we have taken. Oxygen shows -2 oxidation state. That's why we have taken -2. So it is a neutral molecule. The total oxidation state is equal to 0. Since it is a neutral molecule, the total oxidation state is equal to 0. Right? If you solve for X, 2X equal to 2, X equal to +1 will come. Right? So the oxidation state of hydrogen is +1. This is one way of solving. We have another way also. Oxygen we know -2. But the total molecule as a whole it is 0. So we will give +2 over here. Right? Oxygen is -2. The total molecule as a whole it is 0. If I put +2 over here, so +2 -2 total 0. Right? For 2 hydrogens it is +2. For each hydrogen the oxidation state is +1. For 2 hydrogens it is +2. For each hydrogen the oxidation state is +1. In such a way also we can solve. So observe this, you can get clear idea. Each oxygen is -2. There are 2 oxygens, so -4. So sulfur will get +4. total oxidation state is 0, as a molecule as a whole is neutral, that's why sulfur will get plus 4, right? So the oxidation state of sulfur is plus 4. The oxidation state of sulfur is plus 4. If you come here, each fluorine is minus 1. Each fluorine is minus 1, right? There are 7 fluorines, so minus 7. Each fluorine is minus 1. There are 7 fluorines, so minus 7. The molecule itself whole as a neutral, so iodine will get plus 7. Iodine will get plus 7. So the oxidation state of iodine is plus 7. The oxidation state of iodine is plus 7. Coming to here, and one more thing you observe, if there are oxygen or fluorine are present, if there are presence of more electronegative atom, so if you compare a HIO, oxygen is more electronegative atom, so more electronegative atom will always get negative charge, the remaining of atoms will get positive charge. Remember, if there are presence of oxygen is there, oxygen, fluorine are more electronegative, so oxygen will get negative charge here, the remaining atoms will get positive charge. If you take over here, we need to find the iodine oxidation number over here. We need to find the iodine oxidation number. So oxygen, how each oxygen it is minus 2. Each oxygen it is minus 2. There are 4 oxygens, so minus 8. Each oxygen is minus 2. There are 4 oxygens, so it is minus 8. So hydrogen we know plus 1. Hydrogen is no plus 1. So you can ask hydrogen may be plus 1 or minus 1. Hydrogen can be plus 1 or minus 1. But it is present along with the it is present along with the highly electronegative oxygen, that's why it is getting plus 1, that's why we are putting plus 1 over here. Now see, so to make the molecule whole as a neutral, I need to give plus 7 to iodine over here. So to mark the molecule whole as a neutral, I need to give plus 7 to the iodine. Now we check 8, so the total oxidation number is, so the oxidation number of iodine is plus 7. The oxidation number of iodine is plus 7. So coming over here, right? Manganese oxidation state I need to find, right? Oxygen, each oxygen is minus 2. There are 4 oxygens, so it is minus 8. It is minus 8. Here, the sulfur oxidation state is plus 6. Here, the sulfur oxidation state is plus 6. So, what is the charge we need to give here to make the molecule whole as a neutral? So, plus 2 I will give. Plus 2 I will give. So, manganese oxidation state is plus 2. Right, you can solve this in another way also. MnSO4, you know, right? You know total SO4 has minus 2 charge. You know total SO4 has minus 2 charge. So manganese will get plus 2 charge. So the oxidation number of manganese is plus 2. Okay. Coming to here, you need to find for carbon. There are, each oxygen atom is minus 2. There are 4 oxygen atoms, so it is minus 8. So hydrogen is plus 2. H2 is plus 2. So carbon, what will come here? Plus 6 will come here for carbon, right? So 8 minus 8 0, right? Plus 6 will come for carbon, but there are 2 carbon atoms. So we need to divide 6 by 2, right? There are 2 carbon atoms. 2 carbon atoms plus 6 means each carbon atom, that is oxidation state of each carbon atom is plus 3, right? In H2SC2O4, the oxidation state of each carbon is plus 3. Coming to here, K2Cr2O7, right? So each oxygen is 2, 7 oxygens are minus 14. Each oxygen is minus 2, there are 7 oxygens, so minus 14. Potassium always shows plus 1, but 2 potassium, so here it is plus 2. Here it is plus 2. So what we need to put here? We need to put plus 2 over here. So plus 14 minus 14 will become 0. If you observe here, for 2 chromium atoms it is plus 2. For 2 chromium it is plus 2. Each chromium atom it is plus 6. So the oxidation state of chromium is plus 6. While coming to here, it is NO3 minus, right? So observe carefully. It is NO3 minus. Each oxygen is minus 2. 3 oxygens minus 6. The molecule whole itself is equal to minus 1. The molecules whole is equal to 0. The molecules whole themselves equal to 0, but here the molecule NO3 minus whole is equal to minus 1. So here we will put plus 5 for nitrogen, right? Here we are putting plus 5 for nitrogen. So minus 6 plus 5 minus 5 will come. So here nitrogen oxidation state is plus 5, right? I repeat, NO3 minus is there. So the molecule whole is equal to minus 1. So each oxygen is minus 2. There are 3 oxygens minus 6. Nitrogen we need to give plus 5. So minus 6 plus 5 equal to minus 1 is coming. So nitrogen oxidation state is plus 5. Coming to here, fluorine is minus 1. So hydrogen will get plus 1 charge. Right. So chlorine is minus 1 here. Chlorine is minus 1 here. So hydrogen will get plus 1 charge. Right. So fluorine is more electronegative than hydrogen. Fluorine is more electronegative than hydrogen. So fluorine is getting minus charge. Hydrogen is get plus charge. If you take HCl, chlorine is more electronegative than hydrogen. Chlorine is getting minus charge. H is getting plus charge. So HCHO, I need to find first oxygen, it is minus 2. Oxygen, it is minus 2. So each hydrogen is plus 1 and plus 1. Each hydrogen is on plus 1 and plus 1. The molecule itself whole is equal to 0. So what we need to put here? So if we put plus 2, right? If we put plus 2, no, 0, right? So if you put carbon for 0, see, plus 2 minus 2 will become 0. So the carbon oxidation state is 0. I repeat, oxygen is minus 2. Each hydrogen is on plus 1 to make the molecule whole as a 0. So carbon we need to give 0. So here the carbon oxidation state is 0. Next CH3OH, right? Oxygen is minus 2. Hydrogen is plus 1. Here plus 3, right? So plus 3. So the molecule whole itself as a 0. For that carbon, how much we need to give? We need to give minus 2 for carbon, right? 4. We need to give minus 2 for carbon, right? So what is the oxidation state of carbon over here? Minus 2. Okay, minus 2. So here plus 4, minus 4 equal to 0. So the carbon oxidation state over here is minus 2. Next coming to HCO6 4 minus. HCO6 4 minus, right? The whole molecule itself is equal to the 4 minus. The whole molecule itself equal to the 4 minus, right? So each oxygen is minus 2. Each oxygen is minus 2. There are 6 oxygens, so minus 1, right? But we need to get the minus 4 value. So for that oxygen we will give, for xenon we will give, Hc is xenon. For xenon we will give plus 8. So the oxidation state of xenon is plus 8. The oxidation state of xenon is plus 8. In such a way, we can calculate the oxidation numbers, right? So highly electronegative element will get negative charge. The remaining elements will get positive charge. However, some exceptions will come. If you see CH3OH, even oxygen is there, carbon is showing minus 2 charge. Some exceptions are there. In maximum cases, more electronegative element is there means the remaining elements will get automatically positive charge. Well, coming to the oxygen, if you calculate the oxidation numbers, right? I told you here, potassium always shows plus one oxidation state only. Group 1 elements always shows plus 1 oxidation state, right? Here if you give plus 1 or oxygen, the molecule whole itself as a neutral. So the molecule whole itself as a neutral to come 0, we will give minus 1. Plus 1 minus 1 equal to 0, right? So for 1 oxygen it is minus 1. For 1 oxygen it is minus 1. For 2 oxygens, right? For 2 oxygen it is minus 1. For 1 oxygen it is minus 1 by 2 will come, right? So what is the oxidation state of oxygen over here? What is the oxidation state of O2 over here? In minus 1 by 2, right? Minus 1 by 2. So this is called superoxide, right? Superoxide, right? So I repeat, for first year group elements the oxidation state is always plus 1. So for potassium it is plus 1 here. Oxygen, so plus minus 1 will come to make the molecule whole as a neutral. Here minus 1 will come, right? For 2 oxygens minus 1, for each oxygen it is minus 1 by 2. So it is superoxide, right? For BaO2, so secondary group elements always shows plus 2 oxidation state. Secondary group elements always shows plus 2 oxidation state. The molecule itself whole as a neutral. So here minus 2 we need to write, right? For 2 oxygens minus 2, each oxygen it is minus 1. So this is called peroxide, right? If oxygen is showing minus 1 oxidation state, that is peroxide. Oxygen is showing minus 1 by 2 oxidation state, that is superoxide, right? So oxygen is showing minus 2, oxygen is showing minus 2 oxidation state, that is oxide state, right? If you check OF2, oxygen shows positive oxidation state over here. Why? Fluorine is more electronegative than oxygen. Oxygen is showing positive oxidation state over here, right? If you take fluorine, each fluorine is minus 1. There are 2 fluorines, so minus 2. The molecule itself whole as a neutral, so we need to give plus 2 for oxygen. So what is the oxidation state over here? It is plus 2, right? In OF2, the oxidation state of oxygen is plus 2. In O2F2, what is the oxidation state? We'll see now. In O2F2, what is the oxidation state? We'll see now. Each fluorine is minus 1, each fluorine is minus 1. There are 2 fluorines, so minus 2. There are 2 fluorines, so minus 2. So the molecule itself whole as a neutral, so oxygen will get plus 2. Oxygen will get plus 2. So if we divide, for 2 oxygens it is plus 2, for 1 oxygen it will come as plus 1. So in O2F2, the oxygen oxidation state is plus 1, right? In CrO5, right? So what is the oxidation state? We will check, right? So each oxygen is minus 2. The chromium oxidation state I am asking. Each oxygen is minus 2. There are 5 oxygens, so minus 10. Each oxygen is minus 2. There are 5 oxygens, so minus 10. Chromium is plus 10. Chromium is plus 10. But remember, oxidation number is not more than group number. So oxidation number is not more than group number. So here for chromium, right, there is, if in such a cases, if oxidation number comes more than group number, then remember there is involving of peroxy cases. There is involving of peroxy bond. If you write the structure of the CrO5, right, if you write the structure of the CrO5, right, so minus 1, minus 1, minus 1, minus 1, minus 2. If you write the structure of the CrO5, right, so the 4 oxygens show minus 1 oxidation state. The 4 oxygens show minus 1 oxidation state, and the single oxygen shows minus 2 oxidation state, and the total, the chromium oxidation state is plus 6, right? So the total chromium oxidation state is plus 6. If you get the oxidation number more than the group number, so then you assume there is a presence of peroxy bond, right? Now H2SO5, if you check, so oxygen is, each oxygen is minus 2, there are 5 oxygens, so minus 10, hydrogen is plus 2, hydrogen is plus 2, so the molecule itself whole as a neutral, so here sulfur 8 will come, so what is the group number of sulfur? It is 6, group number of sulfur is 6, right, 6 here, right? So but we are getting 8 over here, so it is giving more than the group number. In H2SO5 there is a presence of peroxy bond, right? In H2SO5 there is a presence of peroxy bond. In same way H2S2O7 also we can calculate. So here at the time what you do is H2SO5 oxidation state you don't write 8. H2SO4 oxidation state you don't write 8. Just sulfur oxidation state you mention group number. So simply remember one thing, if oxidation number is coming more than the group number, give group number is its oxidation state. If oxidation state is coming more than the group number, give group number is its oxidation state. Here sulfur 8 is coming, but the sulfur group number is 6, so I am putting sulfur oxidation state is 6 over here, right? H2S2O7, if you take here, each oxygen is minus 2, 7 oxygens minus 14. Each oxygen is minus 2, 7 oxygens minus 14, right? Hydrogen is plus 2, If you check over here, so it is plus 12, right? Plus 12, so each sulfur is plus 6. In H2S2O7, there is no presence of peroxy bond. Why? The group number we are getting. So if we get any number more than the group number, so we can say there is a presence of peroxy bond. I wrote over here, right? If we get oxidation state of an element, more than group number, right? Group number, there is presence of peroxy bond, right? There is a presence of peroxy bond, right? In such cases, we need to write the group number only, right? And one more thing, oxidation number not equal to ionic charge. So what is this? Oxidation number is not equal to ionic charge means, right? If you take, right, nitrogen, right? If you take nitrogen and I will take, what is the charge present on it? N3 minus. If you take nitrate ion charge is N3 minus. If you take NO3 minus, if you calculate the oxidation number, plus 5 will come for nitrogen. If you take NO3 minus, if you calculate the oxidation number, plus 5 will come. But the charge of the nitrate ion is 3 minus. Right? If you check nitrate ion charge means you need to mention 3 minus. But if you calculate the NO3 minus, the oxidation state is coming plus 5. So here the oxidation number is plus 5, ionic charge is 3 minus. So you can say the charge oxidation number not equal to ionic charge, right? In some cases oxidation number equal to ionic charge, in some cases oxidation number not equal to ionic charge. And coming to here, oxidation can be a fraction also, right? Oxidation number can be a fraction also. If you take one molecule Na2S4O6, Na2S4O6, I need to calculate the oxidation number for sulfur. Oxidation number can be fraction also. If you take Na2S4O6, I need to calculate the oxidation number for sulfur. So each oxygen is minus 2. Each oxygen is minus 2. 6 oxygens, it's minus 12, right? Each sodium is plus 1. There are 2 sodiums, it is plus 2, right? So sulfur will get 10 over here. So to make the molecule whole as a neutral, 10 will, if we put 10 here, plus 12 minus 12 will become 0. So sulfur will get 10. 4 sulfur it is 10. Each sulfur 10 by 4 equal to 2.5, right? 4 sulfurs it is 10. For each sulfur 10 by 4 equal to 2.5. So the oxidation number can be a fraction also, right? In such a way we can calculate the oxidation numbers. So oxygen, so there are involvement of 3 bonds, right? Superoxide, peroxide, right? And oxygen measures plus 1 oxidation state also. Oxidation number can be a fraction also. The example is Na2S4O6, right? Oxidation number may be equal to ionic charge or may not be equal to ionic charge, right? If you get the oxidation number more than the group number, right, then there is the presence of peroxyl linkage, peroxyoxyl linkage. Finding the oxidation state for coordination compounds. See, for the coordination compound, one thing while calculating oxidation state, one thing you should remember. So the charge outside the coordination sphere. So this is outside the coordination sphere. This is inside the coordination sphere. Within the brackets is inside the coordination sphere. Outside of the brackets is outside of the coordination sphere. To calculate the oxidation number, the charge outside the coordination sphere and inside should be same. So here minus 3. Here outside of the coordination sphere is minus 3. So inside also we should get minus 3. How we will do? First we need to calculate for iron. Cyanide we know. Each cyanide is minus 1. There are 6 cyanides, so it is minus 6. Each cyanide is minus 1. There are 6 cyanide ions, so it is minus 6. Outside and inside we should get same. Inside to get minus 3, I will give plus 3 for iron. Inside to get minus 3, I will give plus 3 for iron. So minus 6 plus 3 is minus 3. So inside it is minus 3. If we check minus 6 plus 3, minus 6 plus 3 is minus 3. Inside it is minus 3. Outside it is minus 3. So the oxidation state for iron is plus 3. Okay. Oxidation state for iron is plus 3. Check this. Outside it is minus 3. Inside also what we need to get? Inside also we need to get minus 3. So cyanide, each cyanide ion minus 1. There are 6 cyanide ions. So it is minus 6. So to get minus 3 inside also, for cobalt what we need to give? Inside also to get minus 3. For cobalt what we need to give? How much we need to give? So plus 3. So cobalt ion oxidation state is plus 3. Right? Here outside it is 0. Inside also we need to get 0. Here outside it is 0. Inside also we need to get 0. So for copper oxidation state we need to find here. Right? So for that chlorine we know. Each chlorine is minus 1. Each chlorine is minus 1. There are 2 chlorines. So minus 2. Each chlorine is minus 1. There are 2 chlorines. Minus 2. Each hydrogen is plus 1. So to get inside 0, I am giving plus 1 to copper. See here, now plus 1 plus 2 minus 2, 0. So copper oxidation state is plus 1. If you check over here, so outside it is 0. So inside also we need to get 0. Each fluorine is minus 1. Each fluorine is minus 1. There are 6 fluorines, so it is minus 6. So nickel also, to make it 0, nickel we will give plus 6. So the nickel oxidation state is plus 6. The nickel oxidation state is plus 6. Observe carefully here. We need to find for iron oxidation state. For that what you should do is first find the charge on the coordination sphere. First what is the charge present on the coordination sphere? Here charge they didn't given. He given a complete molecule, right? Neutral molecule. So as you know, SO4 charge is minus 2. NADSO4 you know, right? Sodium sulfate. So the molecule itself is whole as a neutral. The molecule whole as a neutral. Here there is plus 2 charge should be present on the coordination sphere, right? Now you find what is the charge on the coordination sphere. Now inside also you need to get plus 2. Inside also you need to get plus 2, right? So to make the charges equal. For that, so iron I am going to find the oxidation state. Here iron I am going to find the oxidation state. NO I know it is plus 1. H2 it is 0. H2 it is 0. So iron also will get plus 1 here. Iron will get plus 1 here. So inside you check plus 1 and plus 1 plus 2. Upon the coordination sphere also plus 2. So what is the charge, final charge for iron? It is plus 1. In such a way you need to form, right? Here outside it is 0. Inside also you need to get 0, right? Cobalt oxidation state is 0. PPH3 oxidation state is 0. So automatically chromium oxidation state is equal to 0. Come to here. Here it is charge. Charge you need to find. Like same like this. Same like this charge you need to find here. So each sodium is plus 1. There are 2 sodium atoms. So plus 2. Each sodium is plus 1. There are 2 sodium atoms. So plus 2. So here the molecule itself as whole as a neutral. So here we will get minus 2. The molecule itself whole as a neutral. So plus 2 minus 2 neutral. So here we will get minus 2. So inside the charge should be equal to minus 2. Inside the charge should be equal to minus 2. Why? Because the charge upon the coordination sphere and charge inside the coordination sphere is equal to equal. That's why inside also we need to get minus 2. As we know, NO is plus 1. Each CN is minus 1. 5 CNs minus 5. 5 CNs minus 5. So iron we will get how much over here? If iron we will give plus 3, right? Iron we will give plus 3. So plus 3 means on iron I will give plus 2, right? Iron I will give plus 2. So inside what we will get? Inside we will get minus 2. Upon the coordination sphere also minus 2. So here the charge of the iron is plus 2. I repeat. First develop the charge on the coordination sphere. It is minus 2. Inside also you need to get minus 2. We know NO is plus 1. 5 CNs minus 5, right? So iron we will give plus 2. Then inside the charge and outside the charge will be give. So final iron oxidation state is plus 2. Okay. Here, so my outside is minus 1. Inside the sphere also I need to get minus 1. Cl it is 1 Cl is minus 1. 1 Cl is minus 1. There are 3 Cls. So minus 3. 1 Cl is minus 1. There are 3 Cls. So minus 3. C2H4 we know it is 0. It is 0. Platinum I will give plus 2. If I give plus 2, see minus 3 plus 2 minus 1. Minus 3 plus 2 minus 1. Inside it is minus 1. Upon the sphere also minus 1. Right? So the platinum oxidation state is plus 2. Here if you check outside it is upon the coordination sphere 0. So inside the coordination sphere also I need to get 0. Right? So sorry. Outside the coordination sphere it is not 0. Potassium is there. I am sorry. So it is potassium is there. Potassium is there. So potassium is plus 1. So it is minus 1. Potassium is plus 1. To make the neutral charge it is minus 1. So inside also you need to get minus 1. For that what you will do, right? So cobalt CO, sorry, it is cobalt carbonyl chloride. CO it is 0, right? It is 0. So to get inside minus 1, cobalt will develop minus 1 charge. So the cobalt oxidation state is minus 1. I repeat, potassium plus 1 on the coordination sphere it is minus 1. So inside also we should get minus 1. Cobalt is 0. Sorry, the carbonyl compound is 0. So cobalt will get minus 1 charge to make it equal inside and upon. So cobalt oxidation state is minus 1. If you take FeCO5, CO for 0, so iron also will get 0 oxidation state. In such a way, you can calculate the oxidation state for coordination compounds.